Okay, hold on. Give me a moment. I think I'm recording. There we go. There we go. All right. All right, section 1.8. I usually exclude this section, but you guys can handle it. You can. I'm excited about this. Linear programming. So, what we're going to do is we're going to start talking about like how you deal with things where you're talking about like cost and profit, right? Like revenue and cost and that type of thing, where those things intersect each other, and we're trying to find out what will maximize profits, okay? So one of the first things they're going to do, linear program is a method for finding maximum and minimum values of a function over a given system of inequalities, within each inequality representing a constraint. So that was a lot of nonsense, right? That didn't make a whole lot of sense to you. Each one of these equations right here, of these three, these are my constraint equations. And we know how to graph those because we've graphed them before. Those three equations are my constraint equations, all right? And then this one tells me my maximum. This is how I maximize like profit or minimize cost. So this is maximizing or minimizing. Okay?
Oh no, I messed up.
Maximize or minimize. Maximize or minimize. Okay, so let's go through, and before we read too far into this, let's go ahead and graph what our constraints look like. So you got your colors here. I'm going to start with this first color that I've been using. 3 is less than or equal to y, which is less than or equal to 6. So that means like your y is bouncing from 3 to 6, right?
Yeah.
So what will that look like?
2 lines across 3 and 6.
2 lines across 3 and 6 on the y-axis, right? And both of them are solid. So 3 is here. Wow, I can't draw straight lines. And 6 is here. There they are. Right there. You betcha. 3, 6. What? Oh no. Oh no. Just relabel it or something. So 3 and 6. Those are at those are my horizontal lines. Yeah?
Yes.
Okay, now the second one, y is less than or equal to 3x plus 12. Is he ready to graph?
Yes.
You betcha. I'm going to graph him in purple. Here, whatever color you want. 12, I don't have a spot. He's like right on the T, so I'm going to go ahead and put him on the T. And then I'm going to go down 3. And to the left 1, right? Because I can't go up 3 and over 1 because I'm off the graph already, right? So rather than going up 3 left, or up 3 to the right 1, I'm going to go down 3 to the left 1, right? If I go down 3, I was at 12 before, I should be at 9, right? And 1 to the left of that. Does that make sense? I go down 3 more, I would be at 6. Down 3 more, I would be at 6. So this guy right here, where he's intersecting the other line, ooh, he might become important. Down 3 and over 1, he's there again. Down 3 over 1, etc. And you keep going. He is going to be a solid line. And we keep doing that, right? Okay? All right, so he does cross those pink lines really nicely, right? My 3 lines are intersecting each other at really nice places, not decimals, right? This place right here where he's crossing, I'm going to do an arrow here. This guy right here is the point, negative 2 comma 6, maybe? Is that what he is? Abouts, yes. And what's this one? Abouts. Negative 3 comma 3? Yes, I don't know. Negative 3, 3. So we've got those 2 points picked out here. That's good. That's really good. All right, now we need to graph the third one. Okay, graph the third one. I'm going to get my other third color out. And we have negative 2x plus 6. So we start at 6. And we go down 2 over 1. Down 2 over 1. Down 2 over 1. Am I doing this right?
Yes.
Solid line again. Yikes. Okay, this guy right here. He's a really nice point where he crosses. Oh, by the way, when you shade these regions, which one is quadruply shaded? If you had to guess, which one was
Probably the middle.
That middle. What's that shape called? It's a trapezoid. Good job, Gracie. It is a trapezoid. This guy in here. If you had to shade him, usually it's the shape that's encompassed in the middle, right? Okay. So there's that guy. All right. So let's figure out where those 2 points are at, where they cross. Right. There's 4 vertices. That's a vocabulary word. 4 vertices of that trapezoid. Vertices are the edges, or the corners, right? So 4 vertices. We've named 2 of them already on the left side. Let's name the 3rd and 4th one. So over here, this guy is what? 0, comma 6. 0, comma 6, okay? And then this one right here does not cross nicely. You see that?
Yes.
But we know where he's located at, even though he doesn't cross nicely. What is he at?
3 is one of them.
Yep, 3 is the y coordinate. So something, comma 3, right? But we started here, and he was right up here at 1, comma 4. And we go down 2 over 1, right? So he's crossing right in between there, right? He was here at 1, comma 4, and then he's here. So where is he crossing? Right there. In the middle between those two, which is halfway in between 1 and 2, which is 1.5 or 1.5. Yeah, does that make sense? Because we know we're going down 2 over 1, we know that he's crossing exactly in the halfway point, right? And I don't have to do my substitution or elimination to figure out what those 2 are crossing. That is crazy. So I have my 4 points. Now, the one last thing that we have to do is we have to find the maximum and minimum values according to this guy. This is a lot of times called your profit equation. This is your profit equation. We're gonna just call him that. There's our profit equation, okay? So these combinations of x and y, like -2, 6 and -3, 3, those are all combinations of x and y. Maybe those are 2 things that I'm making. So like shoes and purses or something, right? And I want to produce those shoes and purses so that it will maximize my profit, right? Or so on and so forth. So they want us to find both the minimum and the maximum. So I have 4 different options here, and I want to know which one will give me the maximum profit and which one will give me the minimum profit. So how can I figure that out?
By looking at the graph.
Kind of, except we didn't graph this thing. This f of x, comma y. We didn't graph him. So he changes things a little bit. That's my profit equation. Let's go ahead and let's plug in each one of these points into there and figure out which one gives me the highest and the lowest. So, if I do -2, 6, what that will look like, it kind of looks funny. Normally we just call it like f of x, right? F of x. But since I have 2 variables, x and y, it's f of xy. Don't let that confuse you, okay? So let's plug -2, 6 in first, okay? F of -2, 6. I'm going to plug -2 in for x and 6 in for y. So this is 4 times -2 minus 2 times 6. Okay, we'll figure out what that guy is. So 4 times -2 is -8. 2 times 6 is 12, and we're subtracting 12, so that is -8 minus 12. -20, okay? So that gives me a -20. Let's see how that compares to the other one. So which one do you want to plug in next?
The one right next to it.
-3, 3?
Sure.
Sure? F of -3, 3. Let's plug him in now. So 4 times -3 minus 2 times 3. You guys see where I'm getting these numbers from?
Yeah.
Right? 4x minus 2y, that's my profit equation. That's what I'm plugging into. So 4 and -3 makes -12 minus 6. And that gives me -18. So we have those 2. All right, let's do the other 2. F of 0, 6 is 4 times 0 minus 2 times 6. And that guy is 4 times 0 goes away, right? -12, okay? And the last one is kind of a lot of plugging in, isn't it? Yep. Equals 4 times 1.5 minus 2 times 3. Do you know what 4 times 1.5 is? 6. Yep, 6 minus 6, which is 0. Okay, so now we have to figure out which one gives me the maximum and which one gives me the minimum. So which combination of x and y will give me the maximum amount, the highest number? Yes, the maximum number occurs with 1.5, 3. Even though that's 0, that's technically the highest number of the 4, right? Okay, and the minimum number occurs, like let's say I was trying to minimize expenses. So maybe this is a profit, but this is expenses instead that I'm trying to minimize. Minimize would be negative 2.6. You're right. Okay, so does that make sense?
Yes.
So now they won't always have you find the maximum and minimum. It will depend upon what your scenario is. So if this is telling me profit, do I want a maximum profit or a minimum profit? I want maximum profit. If this is my cost, so maybe this isn't a profit equation, but this is my cost equation. Do I want to maximize cost or do I want to minimize cost? Minimize, because that's what I'm spending, and I don't want to spend that much, right? So if it's a story problem, I want to minimize cost and maximize profit, right? So I look at the vertices, plug them in, and find the minimum one, right? All right? Good? Good, good, good. Okay, so let's look at this next one. Graph the system of inequalities, name the coordinates of the vertices of the feasible region, blah, blah, blah. Find the maximum and minimum, exactly the way we did before. These are my constraint equations. Constraint equations, okay? I hope this comes out nicely. Pretty please, let it, pretty please, okay? I only have to go up to 12. Poop, 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 poop. Okay, the top equation. Yuck. We gotta solve him, right? This guy right here. So let's kick the 3x to the other side, right? Okay, so I've got 2y is what? 2y is what? Negative 3x minus 12, yeah? And then divide by 2, divide by 2, divide by 2. So y is greater than or equal to negative 3 over 2x minus 6. Okay, is he ready to graph now? Yes, he is. So let's go to negative 6, put our dot. And then down 3 over 2, but I can't go down 3 over 2. Let's go up 3 over 2. Which way do you have to go? Over 2. To the right? This way? If I go to the right, Marcus, my line will look like this.
Just kidding.
But that's positive, right? I want a negative slope, so I've got to go to the left. So up 3 over 2 this way, right? There he is, okay? And I go up 3 over 2 again. I can up 3 over 2 again, etc. And draw my line, and he is solid line. Yeah? Perfect. Okay, now the second one. Let's graph the next one. Let's hope and pray that they come together at nice places, right? Really hope. So the second one, y is less than 3x plus 12. Okay, now 12 is like up all the way off the graph. Crap. So let's just think about this real quick. If we're at 12, 3 over x means I go up 3 over 1, or I can go down 3 and this way 1, right? To the left 1. So if I go down 3 to the left 1, this guy will be at 9, and here at negative 1, right? And if I go down 3 more, where will he be at? 6, and he'll be at negative 2, right? And if I go down 3 and over 1 more, he'll be at 3 and negative 3. If I go down 3 over 1, he will be at, oh, yes. Are you confused, Gracie? Because 3x means I have to go up 1 over 1. But if I'm starting at 12, I can't go up 1 that way 1, right? I'll be way off the graph. So I'm going down 1 to the left 1 until I get back on the graph again, yeah? Okay? So down 3 over 1, I could keep going, down 3 over 1, etc. But, oh man, it crossed really nice. Did it cross really nice? Yeah. Yes, so let's map him out. Where does he cross? About there, Clayton says. About there. Where at? Negative 4, 0, he says. Perfect. Yes, I like it when that happens. So if they cross really nicely, go ahead and map that guy out and show where he is at. Okay. Negative 4, 0. Okay, then the third one. Let's see if he crosses nice. Please, please, please. Please work out for us. Okay, so this one is, we start down at negative 6. Oh, yes. Another really nice one. Right? And up 3 over 1. 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 He crosses really nice, but where's he going to cross up above here? Why not? Doesn't he have to cross? They're the same slope, which means those two guys are parallel, right? Okay. So really, we only have two boundaries, okay? If I would shade all of this, by the way, if I would shade all of this, which region would I be shading?
All the way in the middle.
That one.
No, not the.
That one. Okay, so let's look at the blue one. Let's look at the blue guy, right? This blue guy says y is greater than the blue line, right? So we're shading above here, right? We're shading up and up and up. Okay, the purple line says that we are shading less than the purple line. Which one is less than the purple line?
To the right.
To the right. So we're shading him here and here and here, right? Okay, and if the pink line, maybe it's a different color for you. I shouldn't say my colors, right? The third line is greater than, so we shade him above or to the left, right? So this region is the region that is quadruply or triply shaded, right? And he will continue going up and up and up and up and up, right? So he will be a boundary that doesn't have a boundary at the top, right? Okay? Doesn't have a boundary at the top. So we only have 2 points that we're concerned with, right? Since he is not bounded at the top, that's fine. We'll only have 2 or 3, there are 2 points here. What is this point right here?
0, -6.
0, -6, right? 0, -6. So let's plug into our f of x those 2 points. So let's start with -4, 0. F of -4, 0 is 9 times -4 minus 6 times 0. Okay? 6 times 0 is going to go away because anything times 0 is just 0, right? 9 times -4 is -36. That's that one, okay? So let's try the other one and see if he is more or less than -36. So, oh man, f of 0, -6. 9 times 0 minus 6 times -6. Okay, 9 times 0 is going to go away. What's -6 times -6? Negative or positive? Positive 36, because there's 2 negatives, right? So which one is going to give me a maximum? Yep, this guy is my maximum. That combination will give me a maximum. So if I'm trying to maximize profit, I want to do this combination. But if this is actually representing cost, I want to use this combination because that will give me the minimum cost. Does that make sense? Okay, good, good. All right, now I think they're going to have us do a story problem on the backside.
No.
Yikes, yikes. Let's see if we can decipher it. If not, we'll just maybe, I don't know, we'll see. We'll see what happens. We'll see what happens. We'll see. System of inequalities. All right, an electronics company produces 2 types of smartphone docking stations, which are completely absolute now, right? Did you have one of these ever?
No.
Where you put your iPhone on the thing and then it's a speaker?
Oh, yeah.
These are like ancient, right? I had one that I sold on a garage sale for $6. Somebody actually bought it for $6. $6? That's a lot for a garage sale,
Yeah,
right?
I love it. Double that.
But these, people don't use these anymore because they have like the Bluetooth junk and the Alexas and all that good stuff. I should just turn it.
Hi.
So these are completely absolute now, but we're graphing like different stuff about this dock thing, all right? So an electronics company produces 2 types of smartphone docking stations. A sign on the company bulletin board is shown. If at least 2,000 items must be produced per shift, how many of each type should be made to minimize the cost? Okay, so let's talk about the 2,000 for just a second, okay? If I make 1,000 of one type of dock, how many can I make of the other one?
1,000.
1,000, right? So what's an equation that I can use to represent that in relationship to 2,000? X plus y has to be at least 2,000. So one of my equations is x plus y must be greater than or equal to 2,000. It has to be at least 2,000, right? That's one of my equations, okay? All right, now let's determine real quick which one is x and which one is y, right? Let's write that off to the side over here. So what does x stand for and what does y stand for? Look at the graph. What does x mean and what does y mean?
Basic and multifunction.
No.
Basic and multifunction, right? So these are the basic ones. X is basic. And y is multi. I'm just going to put multi. He's like the snazzy one, right?
Yeah.
Multi, all right? Now, the basic, I'm guessing, is going to cost less, right? Okay? So, basic, let's see. The minimum number of basic that I can produce is how many?
600.
Is how many?
600.
600?
Yeah.
600 is for basic. That's the minimum I can produce. Because that must be meeting like the demand. I know that people are at least going to come in and want 600, right? Demand. So my X, let's talk about, no. Basic was X. Yeah, basic was X. So X has to live in between what two numbers?
600 and 1500.
600 and 1500, right? 1500. Okay? And then let's see, multifunction is my Y's, and he has to live in between. We have to produce at least 800, but no more than 1700, right? Those are going to be my equations that we're going to minimize, or that we're gonna use to graph this thing, okay? Now, I want to minimize my cost, okay? So this function to be minimized, that's like your f of x, y equation. And this for right now is not profit, it's actually cost. And I want to minimize. Want to minimize. Cost that I want to minimize, okay? Now, how is the cost figured out? How do I figure out cost of this thing? Like how much it's costing me to produce X and Y? No? Look at the table. How much is it costing me to produce each X and Y? Yeah, so what will that equation look like? What will the equation look like in relationship to X and Y?
X would be 55. Y would be 9.
Yes, so 55 is X, so it's 55 times X plus 95 times Y. So if I produce one of each, I would put one in for X and one in for Y, right? That would help me determine how much my cost has to be, okay? So now what do we do?
Graph them.
Let's graph them. We have to graph them, we have to find our points, and then we have to plug them in to find maximum or minimum. Which one? Minimum. We're trying to minimize cost. Okay, so let's graph our functions. I'm going to do the first one in blue. Let's do the first one in blue. X plus Y is greater than 2,000. I think 2,000 is my highest number, right? Yes, 1,700 is the second highest, okay? So 2,000 is my highest number. So let's go up here and let's put, I don't know, let's put 2,000 right here. 2,000, okay? Now, what would be half of 2,000? I can't see my lines very well, so I'm just doing it this way. 1,000, so split in half right here is 1,000, right? Then split that in half again. 500, right? 500 is going to go here in half. Does that make sense? Here then is going to go, what is that? 1,500, yeah? Etc., right? Okay. Now, okay, so X plus Y is greater than or equal to 2,000, okay? I want to solve for Y, so I'm going to kick the X to the other side. Y is going to be greater than or equal to negative X plus 2,000. Okay, so I'm going to start at 2,000 graphing that guy, and I go down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. So where is he going to touch over on the right side?
2,000.
2,000 again, right? Down 1 over 1, down 1 over 1 is going to keep going the same ratio, so I'm going to do 2,000s over here. And I'm going to put my dot, and if you have a straight edge, great. Maybe make this really nicely and draw your line. There's my line. Okay, you should look like a perfect isosceles right triangle, basically. Okay, the next one. X has to live between 600 and 1,500. Oh boy, let's label our x-axis. So that's 2,000, then halfway between has to be 1,000, right? Halfway between that has to be 500. Halfway between that has to be 1,500. You see how that's too many zeros. You see how I figured that out? Yeah. Okay. 600. Where's 600 going to live?
Right after
Yeah.
500.
Right after 500. right after here. Boop, 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 boop. Right there. So, right there. This guy is at the point 600, comma something, where he's going to intersect. We're going to figure that out here in just a second. So 600 will be about there. Okay? All right, whereabouts is he going to cross that line?
Yeah.
Not 1500, right? To get to 600, I would have had to have gone over 600, right? So that means that this guy's sloping negative 1 over 1. If I've gone over 600, here, 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 here. You want the middle of tic-tac-toe board? But on which side of the blue line?
Above it.
So if we look at the blue line, y is greater than the blue line. So it's got to be this guy right here.
Yes.